Factoring is the process of breaking down an expression into simpler components called factors. For example, the expression x squared minus 4 can be factored into bracket x minus 2 bracket x plus 2 bracket. This practice is essential for solving equations and simplifying algebraic expressions. Factoring simplifies the solving process for quadratic equations, making it easier to find zeros or solutions. It facilitates graphing by transforming complex expressions into manageable forms, and is foundational for higher level of mathematics such as calculus. Quadratic equations are polynomial expressions of the form ax squared plus bx plus c equals 0, where a, comma, b, comma, and c are constants. They graph as parabolas and can have 2, 1, or no real solutions. A quadratic equation is expressed in the standard form ax squared plus bx plus c equals 0, where a, b, and c are constants. In this format, a cannot be 0, otherwise it becomes a linear equation. Each quadratic equation has 3 key components. A represents the coefficient of x squared, b represents the coefficient of x, and c is a constant term. The values of these coefficients determine the shape and position of the parabola. The graph of the quadratic equation forms a parabola. The vertex represents maximum and minimum values, while the axis of symmetry divides the parabola into 2 mirror images, illustrating the relationship between the equation and its roots. Factoring by grouping involves rearranging terms to create pairs that can be factored individually. This method is particularly useful when dealing with polynomials that have 4 or more terms, making it easier to simplify and solve complex equations. Factoring trinomials requires identifying 2 binomials that, when multiplied, will yield the original trinomial. The general form is ax squared plus bx plus c, and methods like trial and error or applying the AC method can be effective for finding the correct factors. The difference of squares is the factoring method used when an expression takes the form of ax squared minus b squared. This can be factored into bracket a plus b bracket a minus b bracket, allowing for a quick simplification and solution of quadratic equations that fit the pattern. Perfect square trinomials arise from squaring a binomial, resulting expressions like bracket a plus b bracket squared equals a squared plus 2ab plus b squared. Recognizing this pattern allows for efficient factorization, leading to bracket a plus b bracket a plus b bracket, or bracket a minus b bracket a minus b bracket. Select a quadratic equation to factor, such as x squared plus bx plus 5x plus 6. This equation represents a standard form where a is 1, b is 5, and c is 6. Identifying these coefficients is crucial for the next steps in the factoring process. To factor the equation x squared plus 5x plus 6, identify 2 numbers that multiply to c, 6, and add to b, 5. The numbers 2 and 3 fulfill this condition, allowing us to write the equation as x plus 2 bracket x plus 3. This step is fundamental to effective factorization. To ensure the factorization is correct, expand bracket x plus 2 bracket x plus 3 bracket. This results in x squared plus 3x plus 2x plus 6, which simplifies back to x squared plus 5x plus 6. Verification confirms the factors are accurate and showcases the relationship between the equation and its factored form. Engage with practice problems to reinforce skills. Try factoring these equations: x squared plus 7x plus 10, x squared minus 9, and x squared minus 4x plus 4. Solving these will